Welcome back to Dr. Whee's math tutorial class. Today we'll be learning about GCF. What does that stand for? Great Common Factor. Well, what is that? Well, it's a number really. It's a largest common factor, okay? Of two or more number that divides into that set of numbers. Right? That's a mouthful, but let me give you some illustration. For example, let's say you have these two numbers, 30 and 105. And I asked you to find the great common factor for these two numbers. What are you looking for? Well, basically you're looking for a factor where it can divide into these two numbers, but it's the largest, right, number that can divide into. Okay? So to do that, the steps to find the great common factor is to divide individual number into its prime factors. Okay, so here we go. So we have a 3 and a 10, and a 10 can be divided into 5 and a 2. So we have a product factors. Let me just write in order here. 2 times 3 times 5 for 30. And then this one, we have 21 and 5, and 21 can be divided into 7 and 3. And then if I write out its prime factor product, okay, so we have this 3 times 5 times 7. Now you notice that if you look at these set of products of prime factor, you'll see that 3 times 5, right, is common to both. So this would be the greatest common factor found in these two number sets. Alright, so 15. Okay, so 15 is the common factor, the great common factor for 30 and 105. Let's try two more numbers, or two sets of numbers. Let's find the great common factor of these two numbers. We have 126 and 180. So first, okay, the first step is to break it down to its prime factors. So 126 can be broken down to 63 and 2, and 63 can be broken down to 9 and 7. 9 can be broken down to 3 times 3. So the prime factor product would be 2 times 3 times 3 times 7. Now you can circle it to indicate all the prime factors. Alright, and then for 180, we can break it down to 18 and 10, and 18 can be broken down to 9 and 2, and 9 can be broken down to 3 and 3, and 10 can be broken down to 5 and 2. So we have all these prime factors, and we'll group them together to its prime factor product. So 2 times 2 times 2 times 2 times 3 times 3 times 5. There we go. So now you notice that I noticed the greatest common factor, or the largest common factor, 2 times 3 times 3, is also found in this set of prime factor products. So 2 times 3 times 3, that's 18. So 18 is the great common factor to these two numbers. Alright, cool. Let's try one more. This time I'm going to give you three numbers and find the great common factor for that. Alright, here's the last question. Find the great common factor of 90, 168, and 420. So we have three numbers this time. So this is going to be a little bit harder because we have to find the prime factor for individual numbers. So start with 90. We got 9 and 10, and 9 can be broken into 3 and 3, and 10 can be broken down to 5 and 2. So if you write the prime factor product, it would be 2 times 3 times 3 times 5. You see that? Okay, now 168 can be broken down to 21 and 8. 21 can be broken down to 7 and 3. And 8 can be broken down to 4 and 2. And 4 can be broken down to 2 and 2. And so we have these prime factors. Let's write its product. Okay. There we go. And then 420 can be broken down to 42 and 10. 42 can be broken down to 21 and 2. 10 can be broken down to 5 and 2. 21 can be broken down further to 7 and 3. So here we have a prime factor for 420. So let's write its product. So we have 2 times 2 times 3 times 5 and then times 7. Alright. So I noticed that what's common in all three numbers in their prime factor products are 2 and 3. So 2 times 3, 2 times 3, 2 times 3, that's 6. So 6 seems to be the great common factor to these three numbers. So there we go. We have a great common factor for 90, 168, and 420. It happened to be 6. Oops, I didn't mean to be 666, but anyway, it turns out to be that way. So it's number 6. Okay. Next time we'll have more interesting stuff like doing division by hand. Yeah. Okay.